Okay, let's apply these factoring trinomials to a real-world situation, our favorite. So we've got Benjamin. Benjamin is designing a new house. The bedroom closet will have one wall that contains a closet system using 3 different sized storage units. So you can see here's kind of a snapshot of his wall, and he's got just a combination of these different size storage units all kind of arranged. The number and amount of wall space needed for each of the 3 types of storage units is shown. So we can see that we've got one type of storage unit right here that has X units by X units. We've got another type right here that's 1 foot by 1 foot. So we got a big square, then we have a small square, and then we have these rectangles that are 1 foot by X feet. So that's going to have the same dimension as that square. We can see how many of each of those sizes we'll have. We're going to have one storage unit of the X by X. We're going to have 35 of these small units that are 1 foot by 1 foot. And we're going to have 12 of these storage units that are 1 foot by X feet. All right, what are the dimensions of the largest amount of wall space that will be needed? So we need the total area, right? That's going to show us, that's going to be the total amount of wall space. So the total area is we're going to find the area of each type of storage unit and then add those together. So this X by X times X is X squared, and we just have one of those. So we have one of the X squared units. Maybe I'll write that over there. All right. Then we have the units that are just a smaller square. It's 1 foot by 1 foot. So if we multiply those dimensions together, 1 times 1, we get an area of 1. But we have 35 of those. So we have 35 times the area of 1, which is just 35. Then we've got our units that are rectangular. Those are 1 foot across by X feet down. That area, 1 times X is X. And how many of those are we going to have? 12 of those. So 12 times the area of those rectangles, which is X. 12 times X is 12X. So to find the total area, we're going to add these together. We start with our highest exponent, which is X squared. Then we're looking for any X to the first power, so plus 12X, and then plus 35. So this trinomial represents the total area, the total amount of wall space that we're going to take up. Now the question is, what are the dimensions of that? So we know that area is equal to, or is found by taking the length times the width. So what we're going to do is we're going to factor this to find binomials that represent the length and width. Okay, so let's find those dimensions. The length by width, we will factor the total area. I'm going to go ahead and rewrite it down here. X squared plus 12X plus 35. We're going to focus on our C value first. Our C value is positive, which means we're either going to have 2 positive factors or 2 negative factors. Our B value is also positive, so that means we're working with all positive factors. So factors of 35, 1 times 35, 2, no, 3, no, 4, no, 5, yes, 5 times 7, 6 is not a factor, 7 is a factor. We already have it listed, so we have our factor pairs. We're looking for a pair that adds up to our B value of 12, and we've got this 5 and 7. 5 times 7 is 35, and 5 plus 7 is 12. So the binomial factors will be X plus 5 times x plus 7. So each binomial is representing a length and a width. And those could be switched. Maybe x plus 7 is the length and x plus 5 is the width. So to answer the question, dimensions of the largest amount of wall space that will be needed are x plus 5 feet by x plus 7 feet.